So this first question asks us to determine the Z effective for two different elements. One of them is sodium and the other is potassium. We have to remember that Z effective is equal to Z, which is the number of which is the number of protons in the nucleus, minus S, which is the screening constant. So doing the steps that I talked about earlier, we first of all have to look at sodium on the periodic table. What is its atomic number? And the answer is 11. So we're going to start out by doing sodium. Sodium has 11 protons in its nucleus because its atomic number is 11. Now, screening constant. The question is asking us the outermost electron, so we have to first of all write down sodium's electron configuration. It happens to be 1s2, 2s2, 2p6, 3s1. So the outermost orbital in sodium is this one, which means that is the outermost electron. There's a single electron located in its 3s orbital. All of these are inner electrons. So S is going to be equal to the sum total of all these electrons. 2 plus 2 plus 6 equals 10. So the Z effective felt by this outermost electron, the one out here in this 3s orbital, is equal to 11 minus 10, which is 1. Let's compare that with the Z effective felt by the outermost electron in potassium. So for potassium, potassium's atomic number Z is 19. So Z minus S for potassium is equal to 19 minus. To determine what S is, we have to once again draw out its electron configuration. It's 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, I believe. And that's a 4, not a 9, in case my handwriting looks horrible. In the case of potassium, this 4s electron, this one out here, is its outermost electron, while all of these are the inner shell electrons. So S is going to be equal to the sum of all of these electrons. So 2 plus 2 plus 6 is 10, plus 2 is 12, plus 6, 18. So 19 minus 18 is 1. So both of them have a Z effective, or effective nuclear charge, of 1. In the second question that I talked about in the previous video, I asked which will experience a greater effective nuclear charge, the electrons in the n equals 3 level of argon, or the electrons in the n equals 3 of krypton. So let's go ahead and look at argon. Argon Z effective is of course going to be equal to Z, which is its atomic number, minus S, which is the screening constant for the electron in question. Its atomic number for argon, argon's in box 18, which means that it has 18 protons in its nucleus. And then the Z effective, the screening constant we have to figure out by writing out the electron configuration. So argon is 1s2, 2s2, 2p6, 3s2, 3p6. So the question is asking for the Z effective of the electrons in n equals 3. So it's just talking about these electrons right here. So what that means is, for any of these electrons right here, all you do is count the total number of electrons out here as being inner shell electrons. 2 plus 2 plus 6 is equal to 10. That's going to be the screening constant here. So 18 minus 10 is going to be plus 8. That is the Z effective for argon's outermost electrons, which happen to be in its n equals 3 shell. Now for krypton. Krypton has an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, I believe. What's going on is it's asking us what are the electrons, or what's the Z effective going to be for for krypton's electrons in its level 3. So all of these guys, I can completely ignore the electrons in energy level 4 because they're further away. They're not between the electrons at level 3 and the protons in the nucleus. So what I'm going to be doing is I'm going to take krypton's atomic number and subtract from it the screening constant. Krypton's atomic number is equal to is of course the number of protons it has, which is 36. And the screening constant is equal to all of the total number of electrons between the energy level you're looking at, which is 3 in this case, and the nucleus, which is all of these. So all of these combined is 2 plus 2 plus 6 equals 10. So 36 minus 10 is going to be equal to 26. That is the amount of Z effective that krypton's electrons at energy level 3 are going to be feeling. So krypton is going to be much, much higher at energy level 3 than argon. Now, if you were to ask Z effective of the outermost electrons in krypton, those in energy levels 4, that would be a different story.